London has a huge bicycle theft problem. I wanted to show you how, as a GIS analyst, you might approach and say, how can I help in reducing bicycle theft? What parameters can I use and how can I do this analysis? First, you have data on bicycle thefts. So there's a crime website, police.uk, where you can download data, and we have filtered it down to only the bicycle thefts. So these are the bicycle thefts that happen, I think, in a year in this particular region. So you have this bunch of points. There is, I think, let's see, 1,400 bicycle thefts that have happened. So this is one indicator. So I want to find the hotspots and say, can I find where the most thefts are occurring? Secondly, my premise is the bicycle thefts are occurring because there are no secure parkings. So there are database on bike parking. So there are designated parking with a lock facility that's available in this region, and they've mapped all of those. So these are all the existing bike parking. And my theory is that the thefts are happening because there's no bike parking there. People are leaving the bikes in open and people are just taking it away. So it'd be nice to say, where can I build new parking in this neighborhood so that I can reduce bicycle thefts? So to build a new bicycle parking, I would say the new parking should be somewhere close to a cycling route. So these are the designated cycling routes in the city. So this is where all the cyclists go. So the parking has to be somewhere close to the cycling routes. It has to be away from an existing parking, so that if there's a parking, no point building another parking there. And I also want to be on a hotspot of thefts. So how can I combine these three criteria and find where should I build new parking, which is in a bicycle theft hotspot. There is no existing parking nearby, and it's near to a road, a bicycle route. And I want to find those locations there. And we'll go and do this analysis in QGIS. As somebody who loves biking, I was amazed at the kind of depth of data the UK has on bicycle infrastructure. For each of the parking, they have photos along with all the information about what kind of parking and how many cycles can fit in everything. So it's an amazing data set. If you just want to check out this data, go to this data, search for bicycle data on London, and you can find that. Let's start doing the analysis. First, I want to do the hotspot analysis. So let's do heat map. I want to say for each theft, I'll say around 100 meter thing, generate a raster with a 10 meter by 10 meter pixel. And this will be my hotspot. So these are the bicycle theft hotspots. You can see the heat map. You can see there are a lot of hotspots here. This is a raster. I can also style it in a better color so that you can see them in a better color. Right, so these are the hotspots. So now we have done this kind of hotspot analysis. We have found the hotspot. This is a raster where you have some value of the hotspot. If I inspect this, this is 7.2. 7.2 means at that pixel in a 100 meter neighborhood, using this quartic kernel, I found about 7 occurrences of theft. So the higher the number, the more thefts are there in that neighborhood. So there are certain pixels which have value as high as, say, 24, and some values are low. So now I want to figure out what would I consider as hotspots. And this is kind of the basic problem that people face when they do hotspot analysis. I have all these hotspots. What is actually a hotspot? How do I define that? I found this manual. It can have a very clear understanding of how you can do hotspot mapping and how to understand those hotspots. Again, this shows the theory behind all of this. I'll show you this diagram. Because interpreting hotspots is not as simple as, it's not a count of the thefts, it's just an indication of that more thefts are occurring in this region. A better way to do this is using something like this, where you take all the pixel values, compute the average, and then you can say, I will select a hotspot where all the pixels which are 5 times the average. And that's a hotspot. That's much easier to define. You can go to a police chief and say, hey, you have a crime problem. This pixel or this region is 5 times the average crime. Now that makes sense, right? So you can now have a more quantitative criteria saying that anything that is 3 times the average area of crime, that's a hotspot. 5 times the average crime is the hotspot. So this is kind of a useful way to quantify this. First, let's find the average value. We have a tool called raster layer statistics in the toolbox. So I can run this on this heat map, and it gets me statistics. It says the average value of the pixel is 1.25. So I can say 5 times the average value is my hotspot. So I can say 5 into 1.25. Let's use 6 as our cutoff value. And again, I'll show you a model where we can configure this later on. So I'd say 5 times the average value is my hotspot. So I will just do raster calculator and say for this heat map, all the pixels where the value is greater than 6 is 1.25 times 5. So 5 times the average value is my cutoff for being a hotspot. And now you can see these are the white ones are the hotspots. These are the pixels in white which are, I can say, hotspot. The black ones are not hotspots. I can also convert to vector. So convert this to vector. So I get polygons for all the hotspots. And if you look at the output, you have stuff that is for 0 and stuff that is for 1. 1 were the hotspots, 0 were not the hotspots. I can just say extract by attribute and say I take this and say anywhere dn is greater than 0 is my hotspot areas. So now I have extracted the hotspots. So now I have this bicycle theft hotspots, which are 5 times the average crime in that region. And this is how you can quantify it. And and you can kind of talk to people who are doing this in the field, say, how do you select this hotspot? How do you select the cutoff? Well, it's 5 times the average in the region. And that's much more deterministic. So now I have these polygons representing hotspots. That means I want to put my new bicycle parking somewhere in this hotspot. But I have 2 more criteria to be done. So I will incorporate that. Next, I want to say I want to be near a bicycle route. So I have this, I can just say buffer this by 50 meters. I want to be within 50 meters of a cycling route. People are not going to go more than 50 meters to find parking. Buffer this to cycling routes by 50 meters. And I'll just dissolve the result. So this is the 50-meter buffer zone around my cycling routes. So I want my new parking to be in a hotspot and also in this polygon, right? They are, I want both of them to be. So I can just compute an intersection of this. And say, give me intersection of hotspot and route buffer. So these are the areas which are both in a hotspot and are 50 meters from a cycling route. So now I have this intersection that I've computed. So this is the second criteria that I've incorporated. First one, hotspot. Second one, I intersected this with the buffer from the route. So if I put my new parking anywhere here, that will be within 50 meters of a route. I have all the parking facility. I want to put the parking which is away from, at least 50 meters away from existing parking. Then only it makes sense to invest in this infrastructure. So let's compute that. So I have my buffer. I'll buffer the parking by 50 meters. And this is all the buffer zone of my parking. I want to find areas which are on this but not in that buffer zone, which are away from the existing parking. So instead of intersection, we do the opposite, which is called difference. So I found the difference between the previous criteria and the buffer zone of my parking. And now these are my results. So now these are the polygons which I found. If I put my parking here, you can see there's no parking here. This place is also close to cycling route. And if I see the heat map, this is on a hotspot. And that means if I put this, I can help reduce the bicycle thefts in this region. And if you actually go and see this on a Google map, this is actually a park. This path goes through park and there's no parking here. So that means people are kind of roaming around the park, leaving cycles open, and they get stolen. Right, so again, you can kind of see how your analysis also makes sense and do this. You can continue, you can keep adding criteria. You can see how this can get cumbersome as you add more parameters. If you have 10, 15 parameters, you have to keep doing these intersections and overlays. So up to 5 or 6 criteria, this kind of method works well. As I mentioned, when you're doing this for real, if you go and take this to a police chief, they would say, but I want to consider 3 times the mean as my hotspot. Can you do this analysis again? Or can you do this with 50 meters or instead of 100 meters? And then that means it's useful to have a model. So I have built a model that does this. So again, you can see I've built a model that takes the same thing, locations, heat map, raster layer statistics, uses statistics in raster calculator, polygonize, extract by attribute, does all this thing and run this on the default. Let me just run this model and see if we get the same output. Let's run this. You can also make the distance as an input. So I can say, do the 50-meter analysis, do a 100-meter analysis, and so on. And you can get this output. So again, you can see all this output we generated. This is the existing parking buffer, cycling out buffer, theft hotspots, and now these are the candidate locations that we found. Shows you how everything that we learned in the class, all the processing tools, all the expressions, the modeling, etc., can help you solve a real problem like this. And in learning modeling will really help you document this. Somebody said, how did you do this? I said, exactly how. This is how I did this. You can also reproduce this exactly once I have the model. We're going to share this geo package that contains the bicycle theft multicriteria project along with the data and the model. So if you're keen on trying this, you can do this. If you open the geo package, if you open this project, there is a project model, and then this is where the model is. So you now have access to the model. It's saved inside of the project.